So, bell is ringing. It's 2 o'clock and I think 1 minute. So we continue with our presentations around the way to autonomous machines. And and basically I like to welcome here, most likely not Camille Marbach, right? Yeah, Camille Marbach. Yeah. So from Bosch Rexroth, and he will again maybe show us a little bit more about surround sensors and maybe into the safety direction as well, and how to protect ourselves and our employees from the dangerous machines. The stage is yours.
Yeah, ladies and gentlemen, welcome to my presentation. Innovative surround sensing conquers the construction market. My name is Camille Marbach, as Mr. already mentioned. My role is a product manager for surround sensing and automation at Bosch Engineering. Today I explain you why you need surround sensing, what it can provide, and what we can offer to you. First, let's look at the agenda. So in the first chapter, I will give you a short introduction showing the trends and that leading us to our motivation and the services we are currently offering. Then in the second chapter, we will look at some use cases. And in the third chapter, we will have some insight about our products. In the end, leading us to our journey to automation and what we provide to you. So, giving you the trends, you all know that we have an increase in building activities all over the world. Nothing new to you. But at the same time, we have less workers with even less skills. Beside that, we have some government-funded projects, mainly focusing on digitalization and less to zero emissions. That leads us to the Bosch focus areas. So on the one side, automation, coming from driver assistance, getting over surround sensing and with object detection, over self-driving machines to autonomous work machines. Then second focus area, connected, with monitoring and flashing over the air and some other features that are necessary in the future. And in the end, not to forget, electrification. Like we also provide a wide portfolio of electrification components from motors over inverters and many more. But we are more than a component supplier. We are your engineering partner. We provide more than just surround sensing technologies. We are also focusing on these areas you can see on the slide. And we can support you during the integration and conception of your vehicles. So if you're interested, come to our booth and get in contact. Why are we doing that, actually? So we believe more safety is necessary for all participants in the industry, not only the workers, also the machines and everybody around. That leads us to increased efficiency during the work process. And we do it with cost-effective platform approaches based on our automotive portfolio, but with specific adaptations in the off-highway. In the end, that leads to less stress for the operator, because the operator in the end has to perform the job. Or to keep it simple and short, invented for life. What are we actually doing? So here I show you some examples what we are currently focusing on. Of course, most of it is directly connected to surround sensing with object detection, object localization, collision avoidance, and many more. But we are also working on the enablers to automation because the process status is very important. On the bottom left, you can see, for example, a depth map of an excavator arm, which is very important to monitor the shovel fill level. Or another example on the top right. Oops. Oh, yeah. On the top right, you can see the terrain map of a construction site. Very important because you know where you can drive. So now the next slide you have already seen. I show you some Bosch components. Components that we have already in our portfolio today, like the radar, the ultrasonics, and the camera system, but also our upcoming future portfolio based on LiDAR, based on the off-highway robotics controller. And together with our partners, we are also working on other sensors, like time-of-flight cameras, thermo cameras, and many more. Not to forget our electrification portfolio I mentioned in the beginning, on the Bosch engineering side with the 400-volt portfolio, and on the Rexroth side, the 700-volt portfolio. Because I was talking about Rexroth, we are working together with Rexroth. Bosch is one big company. So actually, our sensors, the multi-camera system, the ultrasonics, and the radar are already today part of the BODAS hardware ecosystem. As you can see, many more sensors and components are in that portfolio. But beside the hardware portfolio, we are also working together for the sales and service network, and we are doing common engineering projects, like the off-highway robotics controller, which is a joint project between both companies. BODAS, that stands for Open, Scalable, and Easy Access. Now, I want to show you some insight in use cases in the construction area. First, the object localization with our ultrasonic sensor system. You all know those ultrasonic sensors from your private car. What we have here is an adapted solution for increased safety for the machine and its environment. Because accidents are critical, large machines are dangerous, and big machines often unclear with large blind spots. In this case, the ultrasonic sensor system with 12 sensors for 360-degree coverage of the machine is very suitable. Next, oh, forgot the video. In the video, you can see my colleague walking next to the vehicle with the ultrasonics detecting him at the time. Now, the second use case, collision avoidance with our radar sensor. Because nobody wants a crash with a large construction machine like a wheel loader. This is, for example, useful if you have a dump truck approaching the machine. It works up in larger distances, up to 160 meters, but comes with advanced filter settings specific for the off-highway, like ground reflection filter and many more. It works for static and moving object detection and provide you some metadata of the objects, like the speed, direction, angle, and much more. Also, the radar is perfect for complicated environment conditions like dust, snow, fog, and many of those. For the radar and for the ultrasonics, a warning that is given to the operator via acoustic or visual interface is ideal. But it also is the input for our automation controller in the future, giving the system the necessary surround information. Our third use case is, oh, I forgot again the video, sorry for that. So you can see in the front the radar echoes detected on the screen. I'll show it in the screen. The operator assistance with our surround view system, because it's often hard to observe the work process and the machine surrounding at the same time. So to improve safety and reduce the mental stress of the operator, those camera systems are very popular. With our 360-degree camera system, there are no more blind spots around the machine. This physical and mental ease leads to efficient and therefore also faster work processes. The system can be used with or without a warning, although the driver remains in responsibility at all times. Here, the example, the machine is going in reverse into a storage area or in the workshop, which is very handful with the trajectory line. And our fourth use case today is the vision system of highway with our prototype system, combining all previously mentioned technologies in one single system. So that one is targeted to OEMs and integrators that want to find out which sensor technology is the right one or which combination is the right one for my use case. Therefore, this accelerates the development time and leads to better decisions. I have two examples on the left side, the excavator equipped with 4 radars, 12 ultrasonics and 1 multi-camera system. So the sensor positions are based on the operator blind spots for perfect coverage. On the right side, we have a system with less components. So 1 radar, 8 ultrasonics, and 1 camera system. So those sensors are also positioned in the dangerous areas of the machine. The operator has usually a good sight in the front of the machine, but not in the back area. So that's a very flexible system, isn't it? And that were our use cases for today. So I want to give you now a bit more details about our sensors. First, the ultrasonics. It is based on an ECU and up to 12 sensors. So you are flexible with your sensor layout. But you can cover the whole machine surrounding. They come with a fast reaction time of up to 120 milliseconds and with high protection glass as well as 12 or 24 volt supply voltage. Additional features like sensor blindness detection in case of dirt or soil and sensor blindness and sensor status monitoring available in the system. Next, the radar. So the radar is available in 2 versions. One, the general purpose radar with 48 target reflections, giving you the more or less raw data, and the radar of highway, which is giving you the information about up to 40 objects with zone information, tracking, speed, and all those informations you need for the use case. They go along with blindness detection and ground reflection filter, as I already mentioned. And as my previous colleagues also mentioned, this sensor operates in the frequency range of 76 to 77 gigahertz. With its precision of up to 10 centimeters at 60 meters with 6-degree opening angle, or an even wider opening angle of 42 degrees at 29 meters, it's perfectly suited for the bigger machines in the off-highway area. And with this system, you can perform safety requirements up to performance level D. So for the radar and for the ultrasonics, we also have a tool called OneCVT. This one you can actually use for visualization, parameterization, and also diagnostics of those components. Now the multi-camera system comes with high resolution of 1280 by 800 pixel, giving you the best details in every blind spot. So it comes with best-in-class stitching. That means perfect overlapping between the single cameras. Zoom functions and graphical overlays are also available, either manual input or via vehicle signals on the CAN. Configurable views and virtual camera positions can be configured in the specific tool that can be used alongside the parameters also for calibration and diagnostics. And in 2023, we will also launch a retrofit solution of it, coming together with a harness, brackets, and a display. Now, some details about the vision system. As I already mentioned, all previously seen sensors can be combined in one system based on ROS environment. So this gives you all information at the same time on one single display. Different combinations of the sensors are possible. In the maximum, 4 radar sensors, 2 ultrasonic sensor systems. And the outputs of the system can be used for further processing, for example, to test a vehicle reaction. This development kit is ideal to choose the sensor technology and the sensor position based on our already available products on your machine. And now, outlook to automation. So today, we are mainly focusing on assistance systems. Like I already explained, radar and ultrasonics combined with visual warning or some audible warning. But already tomorrow, we will have partly supported and automated tasks. Excellent examples for that are the grading or the center tool point you can experience at our Rexroth booth. Come and see it and test it. Bosch believes that there is a stepwise approach to automation necessary. So for that one, in future, we will have partly and full autonomous work machines, especially for tasks like handling of bulk cargo, land leveling, land compacting, and many more processes. Especially those simple and iterative tasks are perfectly suited for the introduction of automation. But how can it be realized? So for that one, we are started the development of our off-highway robotics controller. With that controller, partly and full autonomous work machines are possible. We are working together with Rexroth and other partners to provide that high-performance solution to you. It enables OEMs and their partners to offer automation projects in serious qualification. Because with that one, you can get rid of the industrial PCs and the development boards on your machine. And the level of support is based on your decision. So we have, on the one hand, the hardware-only solution over hardware together with software and up to full automation projects. Because I was talking about the software, we are developing a software called Perception Stack, which is performing the fusion and pre-processing of our sensors. So this gives you the whole surround information of your machine. So this stands for open with ROS2, holistic with a wide range and number of interfaces, and safe with performance level D. We are the partner for your automation journey. Now it's time already to thank you for your attention. I have a QR code here. You can get to our webpage and get a white paper about automation and also data sheets from our sensors. I'm looking forward for your questions, ideas and discussions, either here or at our booth or with my colleagues on the fair. Thank you.
Yeah, thanks a lot for this interesting presentation. Are there any questions from the audience? There. One. Yeah.
Hello, I'm a university student, and I'm doing my master thesis on automation in above ground and underground mining, and the current state-of-the-art technology that was being put to it. So knowingly, sensor fusion can be very expensive, and especially the CPU that the CPU required to collect all that different data from different types of sensors together and then forming it into your software perception. I was wondering, like, what are the chances of like the scalability of that and the marketability of that? Is it possible for it to bring into market, considering CPU can be so expensive, and then putting it onto machines that aren't as required, if that makes sense?
Yeah, so we believe that it is possible because we started to work on it. For the sensors you mentioned, so we are in the beginning focusing on our radar sensors, ultrasonics and the other stuff, and giving them with a driver interface into ROS2, and then we develop the sensor fusion in ROS2, which then can be also used on future hardware platforms, and is relatively flexible on which hardware you actually use it. So we started to go with this approach, combination out of microprocessor and microcontroller hardware, providing the inputs from our sensors via the CAN bus on the microcontroller, giving it in the same time rate, everything together at the same time, and providing it together with additional sensors, like for example a LiDAR sensor that is connected via Ethernet on the microprocessor. Yeah. Is that answering your question? At least partly?
Somewhat answering my question. Hello? Okay. It is somewhat answering my question. My real question is, since, well, from what I know from the research I did, is that in order for automation to happen, the eyes, the sensors, has to work, right? And bringing all those sensors together into that CPU itself is extremely expensive, correct?
Okay, what I might forget to mention is that all our sensors do already pre-processing in their control unit or the radar in its unit itself. Okay. So it gives out the informations on the CAN bus, and we're just aggregating all those informations from on the CAN bus in our controller. And with this controller, it is possible to do it in a reasonable price.
Okay, thank you.
Yeah, another question maybe.
Hello. I have one question regarding the lidars and the sensors themselves. It's surprising for me that such a large company like Bosch is not, or apparently not active in that 2D, 3D LiDAR sensor area itself. Is the perception right? We do see the SICK, for instance, as the major provider. And if not so, or if you're not active in that area, why is that so?
In principle, Bosch is active in the LiDAR area, but focusing on the automotive industry. We were getting the data from the colleagues, and we said, okay, it's not suitable for the construction market. That's the one side. And the other side is that we said, okay, before we start to develop our own solution, which would be very expensive alone for the construction market, we look for partners, because we reached out to some companies and they said, we are looking for a controller that can do the processing of that data. So in that case, we believe that they focus on their area, the LiDAR technology, and we focus on the controller, which is our major domain. Two points mentioned, one last one again, one last one attached to it. For me, it's not yet clear if LiDAR is the health-bringing solution for the whole industry, because it's an optical system, and as we all know, in construction area, optical systems are used with limitations. So maybe in future we have also other sensors. For example, our radar sensors look promising in those areas, so we might use radar sensors in the future, like a high-definition radar or what else.
Yep. Another last question, maybe? Then maybe I will ask a question. Seems like the sensors are there, available. What is, in your opinion, right now the biggest bottleneck in coming to autonomous machines?
Yeah, good question, actually. I think a large bottleneck is the missing test data of such sensors. Like, we all have these sensors available, but there is no public database yet for like radar data collected in a construction environment, so that Bosch and other companies can work on that data and perform analysis on it to see what's actually possible with it. So that is definitely one point that to be solved.
Okay.
Yeah.
Yeah. Thanks a lot. Yeah. So then I say thank you to you, and I'm sure you're available for more questions as well in your booth. So feel free to ask. And then yeah, I think maybe we can come already to the next presentation, which is already mentioned here. And I think this is maybe a place where you can get some example data. Because